Good evening, everyone.
How are you?
Yeah.
Good evening,
I'm
everyone.
well, thank you.
Tonight is our last class session.
Professor, I've been more absent for 2 days, and I've been here for both days.
Yeah, I saw your email. Let us take care of it after the class. Okay.
Okay, thank you.
You're welcome. So tonight is the last class. Now, let me by this Saturday or Sunday, I'll have all your work graded. So try your best, I would say, to get everything done by Sunday, and then to take your final exam, which I will put probably tomorrow night, so that you can take it anytime you want till on the Monday's deadline. So that's about it. When I finish what you have tonight, you have everything you need to finish your homework, finish your project, and what else? Finish your project, homework, and final exam, and that's it. Now, tonight we'll be working on regression analysis and the correlation. All this time we have been looking at variables and every other thing about variable, test of hypothesis, confidence intervals, and so on. But now we are going to put them all together by looking at the relationship between two variables, how two variables relate or connect or move together. We know that can happen. So that's what we use correlation and regression to do. So correlation basically describe the measure of how or the two variables, or the extent to which two or more variables move together or fluctuate together. So, and we use regression to measure the attempt or to determine the strength of the relationship between the two variables. We call those two variables X and Y. Now, let me give you a hint at what we are doing here with regression and correlation. What we are doing here is trying to figure out how one variable determines the other variable or not. For example, a business owner might want to know whether the volume of sales increases or decreases because of the advertisements that they did. So does expenses on advertisement, does it affect sales volume? Or an educator might want to find out if the number of hours the students studied affects their grades. Does it increase the grades or not? To what extent, if it does? Now, a medical researcher might want to know, does age affect blood pressure, and to what extent? Or does COVID-19 vaccine really protect us from disease? From the disease, things like that. Now, there are two types of variables. We have the dependent variable, which we also call the Y variable, and the independent variable, which is called the X variable. Now, the dependent variable, excuse me. I want to make sure everybody's seeing this. Okay, good. The dependent variable are those ones that the researcher can, or we can control. Sorry, we cannot control. Now, things like cells, good health, and grades. Now, cell. Let me give you an example with cells. We can control how much we spend on advertisement, or how frequent the advertisement can be, but we cannot control how much sales that will come from that advertisement. So we don't have control over that one. For good health, we can control the amount of exercise we do. We can control our diets, but we cannot control the degree of good health that will come from those. All we know that when we do this, we'll be healthy, but to what extent, we have no control over that. The same thing with the grades. Yes, I know that if you study hard and study the right thing, your grade will be good, but to what extent? you have no control over that, but you know that indirectly, your hours of study can increase it or decrease it, you know. Now, the independent variable are the ones that we can control. Like I said, advertisement expenses, we can decide how much to spend and spend exactly that amount. Exercise, we can decide how many times to exercise in a week and do that exactly. Dieting and hours of study, these are the independent variables. So we call them the X variables. Now, sometimes there can be many X variables. Because there's only one Y variable, then multiple X variables. When we're talking about multiple regression. But for this class, we'll be focused only on simple regression. Now, how do we determine the degree to which the two variables move together? We use what we call the correlation coefficient rho. This is the symbol rho. The correlation coefficient tells us to what degree does the two variables move together. There are many types of correlation coefficient, but the one we'll be using for this class is what they call Pearson product moment correlation coefficient, which is named after the statistician that developed it, or did a lot of research on it. His name is Carl Pearson. I believe he's a German statistician. Now, that's what we'll be looking about. So in what we'll be doing, we'll be trying to estimate this symbol rho, the population correlation coefficient by using R. So using this one R here, which is the sample correlation coefficient to estimate this rho. Now other things we might be doing then is to get the regression equation. But before then, we need to figure out what are the range of values for the correlation coefficient R. It varies from -1 to +1. See? So if you look at this diagram, you can see that when it's at 0, it means that there is no correlation. For example, death rate from COVID-19, and let me write it down here. Death rate from COVID-19 a day and versus not up a day. Let's say per month. If I can even make it per day, like per day versus stock trades, volume of stocks traded per day. See, these are not correlated at all. So you can find zero correlation or a very weak correlation between them. Now, halfway, 0.5, you see there's a positive correlation. As it goes to the right, it becomes stronger and stronger. So strong positive correlation. But you can also go backward on the left side, where you have negative correlation and then strong negative correlation. So this is how it is best illustrated by this chart here, this table here. If you look at it, when it is 0 to 2.2, it's very low correlation. Like this example we did here. You're gonna correlate a little bit, but it's gonna be very low correlation, like 0 to 0.2. Now, when it is about 0 to 0.4 is low, 0.4 to 6 is moderate correlation, 0.6 to 0.8 is highly moderate, and when it is 0.8 to 1, it is very high correlations. For example, very high correlation can be smoking and lung cancer. See, can be a very high correlation. So or even high to moderate correlation, because there's many people that smokes. If the correlation is 1, for example, if it's 1 plus 1, that means if you smoke, you've got lung cancer. There's no argument. But it's not like that. It can be like 0.5, which is which can be moderate correlation, things like that. Any questions so far? Any question? Now, for negative correlation on this side, it is for things that move in opposite direction. For example, speed and time. The higher your speed, the less the time. The lower the speed, the more the time you arrive at the destination. This one move together in the same direction. For example, hours of study and grades. If you increase the hours of study, you increase your grades. Unlike this one, whereby one variable increases, the other one decreases. Okay, let's look at the scatter plot. The scatter plot is a visual way of showing the relationship between the dependent variable and independent variable. Like here, if you remember from your algebra class, you have your x-axis. This is x variable, and this is the y variable. If you plot them, and the plot the points clustered in a straight line going up like this, we say that it indicates a positive linear relationship. Example, hours of study and their grades. One variable increases, the other one also increases. Hours you worked and your paycheck. The more hours you work, the more your paycheck, the bigger your paycheck. Things like that. Now this one, where the points are clustered at the middle, but they are trending downwards. Now this indicates that cluster at the middle, and if you can see the line of best fit goes down, it's trending down. A strong negative linear relationship. So I mean, when one variable increases, the other one decreases. I'll give you an example with speed and time. The higher speed, the less time you arrive at your destination. I mean, assuming that you didn't crash the car, the higher the speed, the less the time. There are many examples of that you can give. I encourage you to explore, similar example. Now, this one is when they are not figure 3, when they are not correlated at all. See, it doesn't show any pattern. So this indicates no relationship, no linear relationship. Okay, between x and y. This is x and y. Here there's a negative relationship between x and y. So we'll add them. This one, this other one. Between x and y. This one indicates no relationship between x and y. Now, then the correlation coefficient, coefficient of determination. Now, this coefficient tell us we use it to explain how much of the variability of a factor that can be caused by or explained by its relationship with the other factor. I'll explain that when we do an example so you can understand it better. Now, the regression equation is a measure of the extent to which researchers can predict one variable from another, specifically by using a equation like this. We go this way: y equals BO plus B1x, where BO equals the y-intercept. And B1 equals the slope. And B1, B2, B1, and B2, and B1. Okay. Okay, B1, B1. Okay. So BO is the y-intercept, and B1 is the slope. The slope, as you know, slope is another way of defining slope is a slope means the rate of change. So like I said, I'm going to give an example of this. When we do an example, then I will explain it. I will explain each of these one by one. Okay. So that's this is the regression equation right here. Now to find this R, remember this R, the correlation coefficient. This simple R. Right? To find the value R, you must calculate all this. You will find answers to these formulas here. This formula, okay. Now sum of squares for X, this is the formula. Sum of square for Y, this is the formula. Sum of square for the interaction of S and Y, is the formula. Then with that, you can find a slope as SSX, SXY over SSX. So now find the y-intercept with this formula, then find the correlation coefficient with R by plugging the answers for these three into here. Any question? Any question, class? Can you hear me? Hello?
Yes, I can hear you.
Yes.
Okay, good.
Yes.
Now, using this formula to get this R to be this point might take you, if I give you a question, it might take you at least 1 hour to calculate all this and then get an R. Because usually this kind of question, when you rush it, you might make mistake. So you have to go slow. So as to save us that time and problem, you're gonna use an Excel to do it. Something that might take you up to 1 hour to do, you can do it in Excel in a few minutes. Now, before we do that, another way you can calculate R is to use this formula too. Just this formula here. You can see how complicated it looks. I mean, it takes you a while, but because you have to make the table of values and then start putting all this in your calculator. So you take it right. So now we're using Excel. Once you put it in Excel will give us the whole results. Now it is now up to us to interpret them and interpret them properly. Let's do one example before. Yeah, let's do one example for now. Okay. Right. Let's see. Now it says here, make it big. I think I'm gonna move it down. Let me move it down so we can have more room. Okay. I can make it bigger. All right, a little bit big. Now, question says, in a random sample of M, which is 9 steers, the live weight and dress, steer is the type of, I think it's the type of beef or something, I believe. The live weight and dress weight were recorded. In the table below, let Y denote the dress weight. And why is it therefore why is it dependent variable? So therefore in hundreds of pounds, and S denote the corresponding live weight in hundreds of pounds. Use the sample data to obtain the least square estimate for the regression of the regression equation. That is, find the regression equation using the least square method. Now, remember, this is in hundreds of pounds. So this 4.2 might be 4,200 pounds. This will be 3,800 pounds, you know, stuff like that. So they want you to use it to find the regression equation. I find the regression equation using the least square method. Okay, this one asks us to find the regression equation. That means we don't have to calculate all this, calculate this, then calculate our y-intercept, calculate our slope. Then we can plug it into the equation y equals to beta 0 plus beta 1x. But we can do it in Excel faster than plug it. But remember that this is the regression equation right here. Yeah, copy it. So if you're using Excel, you don't need to use those formulas. Okay. So now, solution. So this one, you know, Excel will give you all the results. The result it will give us, we will only choose the regression equation, because that's what it asks us to find. Oh, I think I did it wrong. Did it wrong. Yep, under it, solution. Okay, so like I said, Excel will give us all the results, but we take only the regression equation. All right, make it big. Okay, so the first thing what to do is we know what is the life weight and the dressed weight. So you copy from here. Okay, copy it and go to your Excel and paste it. Then type in your life weight and dress weight. Okay. So I'll copy this now. I'm going to take you to my Excel so I can share it. Okay. So I'm going to close it here. Now, okay, let's say paste options. I pasted it. Remember, the one on the left side is the dressed weight. What is it again? Yeah, that's right. The one, sorry, is the life weight on the left side, life weight, and the dress weight is on the right side. So life weight at the dressed weight. Life weight. Right here. This is live weight. Okay, dressed weight. Dress weight is the y variable. Okay. Live weight and dress weight. Let's see. Right. Now with this, we are ready to do the answer equation. The first thing you do is to just click on run the test. Data analysis. Yes, you click on data, you click on data analysis. Then you choose regression from here. This is regression right here. And click OK. Now for the input for the Y range, it's dressed weight. So click on that and then okay, click on that. Then start from here. Now you include the name, which is dress weight. Okay, that's the Y variable. Okay. Now for S variable, is the dress weight, the live weight. So you click on here and then click on the live weight. Include name or title of it. Yeah, and then got it. Because it included your names, so you gotta check labels. Okay, if you want confidence interval, you can check confidence level and interval. Okay. If you want output range, put it right here. Output, you can say put it under it. Okay. And what else we need? Maybe we might need residuals. Our standardized results. Now, I think line of the scatter plot. If you want the scatter plot, we can put it as well. It is important because in Excel it doesn't tell you if it is it doesn't give you a negative R. Even though that the two variables might have a negative relationship, Excel doesn't give you the R. So that's why it's better to include the line of fit, so that when you see the direction of the line, you know whether it is negative or positive. So after you click all this, click OK. You see a result right there with this plots. See, it gives you the plots, the scatter plots, give you the dress weight and life weight. Now, if you are doing a project, let's say that this is a project. You can just click on here, copy it, and then go to your project, whatever it is you're typing it, and then paste it there. And then, start typing your work, life weight, whatever it is you're typing, start typing.
Excuse me, Professor.
Yes, ma'am.
What question is this?
Huh? What question?
Yes.
It's right here. It's right here. What is it again? Isn't the hand is under here, right here? See?
Okay, but you said the class is starting by 6:30.
I said that was for yesterday.
Oh God.
Oh, yesterday and day for yesterday. Today I didn't say 6:30. Are you just joining us?
Yes, I've missed a lot then.
Well, the topic it come under regression. So what I'm gonna do is I will upload this video so you can watch it.
Okay, thank you, sir.
And based on what you say, that some people are just joining now. That means they have the wrong. They assumed, they assumed that, but it was only for yesterday and the day before yesterday. Anyway, so you have seen the question now, right? Hello?
Yeah.
Okay. Now let us finish this. So you can see that it gives us the plots right there. Now let us answer the question. Was asking us to. It was asking us only one thing in that question. It wants us to find the regression. So use the data to obtain the least square estimate for the regression equation. That is to find the regression equation using least square method. Like I said, this will give us what we need. And this is the general model of the regression equation is right here. I'm gonna copy it, then we put our BO and B1. That will give us the equation. It's right here. So now our regression, so the regression equation becomes, we have 10 minutes left. Our regression equation, the regression equation here is, okay. Now, let me tell you how. So to get that equation, we need our B1, some B2. Sorry, B1 and B1 and B0. This is B0 right here. So I'm gonna make this B. Okay, and B1. Where B0 is the intercept. Okay. All right. Once we got that, then we can just put them in the equation. Good thing that Excel have given us the answers to them. So we just plug it from Excel. This is my pen, paper. So going back to our work in Excel, you will see that from here, our B1, you can see it right here. See what we have the coefficients. This is your intercept right there, B0, and this is your slope. So usually we use it at 3 decimal place is enough for it. So let me make it a little bit bigger. You can see both of them right here. This is there, B0, and this is your B1. So rounded, this will give 0.0, BO is 0.086. I got it right here. BO is 0.086, and B1 is 0.616. 0.616. So let's go and put it and then write our regression equation, since that is the only thing that he asked us to do. So B0 is 0.086, and B1 is 0.616. Now, so that the regression equation now becomes, I'm gonna bring it up. Our regression equation now become is y equals beta 0, which is this one here, is 0.086 plus B1 is 0.616 x. That is our equation right there. Now, what does this mean? What does this equation mean? What does it tell us? It is telling us a lot of things. Now, if you look at the original equation here, it says that this is the live weight. This is for 9 steers. The live and dress weight were recorded, and all these are in hundreds of pounds. And remember, I told you that slope is the rate of change. So this 616 is like 61.6 pounds if you multiply by 100, because all these are in hundreds. For example, this one, if you multiply this by 100, you get 4,200 pounds. So with this, it means the slope interpretation, it means that this slope of 6.616, which means if you multiply by 100, it means 1.6 pounds. So the slope of 0.616 means that the dress weight, because it is positive, that means positive means increase. So it means that the dress weight increases over time at the rate of 61.6 pounds for each 100 pounds increase in the live weight. So the dress weight, the slope of 0.616 indicates that the dress weight of the steers increases over time at the rate of 61.6 pounds per 100 pounds increase. And the dried weight, in the live weight. Live weight. So this is your equation, regression equation right there. Okay. And this is the interpretation of it here. Questions? Any question? Can ask. I think this one is easy. So they are together. We have 3 minutes left. And Miss Olubis is there, right? Miss Olubisi, are you there?
They were largely silent. Dick Cheney told me, quote, "I'm deeply disappointed we don't have better leadership in the Republican Party."
Hey, please mute yourself. Whoever is saying, please, can you mute yourself, please? There's no question on this. That means we're good. We have 3 minutes. We cannot achieve much in 3 minutes. So I'm going to time us out. Please log back in 10 minutes so we can finish up. Okay?
Okay.
All right.
Okay.